Good morning, friend. Today we are going to discuss about the action potential or conduction of nerve impulse in neurons. Basically, when the neurons they communicate with each other, there is a two-way. One is graded potential, other is the action potential. Or these graded and action potential basically depend on the certain feature of plasma membrane which have an potential which is the resting membrane potential due to presence of different type of ions. Or during excitation, there is a electrical changes in the plasma membrane to that cause the electrical signal that pass through the from one side to the other. For this electrical signal, they are depend on the key voltage difference or electrical difference, or these two you can understand with the in two way. One is on the basis of diffusion, other is based on the electrical charges. So as you know, that's the key our these cells, you see the battery, so it's have an non insulated material inside the between the two. It's a in two sides they work like that. The relation, these ions actually they diffuse from higher concentration gradient to the lower concentration gradient, and the diffusion of these ions they 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 diffuse from one direction to other direction against the concentration gradient. This can be understood with the help of next equation, which is for the development of electric EMF, electromagnetic potential. Electric magnetic potential. For this potential, it's a the greater this ratio, the greater it's basically the ratio between the charge of outside and inside, a concentration gradient of outside and inside of a particular ion, or EMF, which is developed electromagnetic potential force which developed by these ions are equal to plus minus 61 by Z into log concentration inside and concentration outside of a particular ion. But you know, for a Z where the EMF is the electromotive force and Z is the electrical charge on the ion. For example, for potassium it's a plus 1. But you know that there are different kinds of ions which are present inside and outside the cell membrane, plasma membrane. So for that purpose, for different ions, several ions, we use the Goldman equation to calculate the electromotive force of a membrane, electromotive force of a particular plasma membrane, a particular neuron cell, which is equal to minus 61 into log plus the pressure and the concentration of these ions outside and inside and by oblique outside of these ions. On the other way, you can understand, as you know, that's the capacitor which have an insulating membrane in between the two. Our extracellular and intracellular concentration of ions work like in the same way. The conductive region of capacitor is represented by the intracellular and extracellular solution in the cell, and the non-conductive material, which is a separation between the two, is a plasma membrane. As you know, that the lipids are the electrically neutral ions which are made up of our cells. The conduction of charge in electric field, when this region they accumulate the charge, they push the charge of the subsequent conducting region. When there is a one conducting region accumulate, the charge is passed to the other one, which puts the and this phenomena occur in a short amount of time, producing a brief current, which are expressed as current, electricity I is equal to C upon difference is voltage into time. It's in time duration. What kind of, how many differences occur in voltage? Or this, and when the charge moves, there are, that there are gates which are the open and close. The opening or close actually decrease the resistance, and the closing of these voltage gate channels, it increase the resistance. So you can say, you can apply here the Ohm law, or Ohm law say V is equal to IR, I is equal to V upon R, where R is the resistance represented by current, I is current, V is represented by voltage, and R represents the resistance of the जो हमारा न्यूरॉन, या कि न्यूरॉन्स के बीच में जो प्लाज्मा मेम्ब्रेन है उसका resistance. So for that purpose, as I say earlier, there is a channels. There are 4 channels which help in conduction of these electricity or impulse, electric current that pass through the different regions, along the axis of neurons. So one is the leak channel. Here I represent it in a D1. Leak channels, these channels are present in an alternate way. They may be open and closed, they are leaky, like the potassium in our membrane. There are the more potassium channels are leaky one. They pass the ion from intracellular to the extracellular environment of a neuron by the leaky channels, or they are mostly present in the dendritic and cell body region of a neuron. Other channel is a mechanical gated channels. Mechanical gated channels, there is a mechanical interference in a field, like the touch receptors and pressure receptors. They are the mechanical channel, and in your skin or in your body there is a touch, you feel sensation, or that sensation is lead to the causing, it lead to the opening and closing of the channels. These are the mechanical channels, so they mostly present they also present in the dendritic cells, and most of the cells like the skin, they present here. Another one is the chemical gated channels, or ligand gated channels. These channels open and close in response to on binding of a particular ions. A particular chemicals, they open only on the time. Okay, so these are known as the ligand gated. Most of the time they are present all this neuroreceptor, like the neurotransmitters. They are ligand gated. Vesicles which open in response to a particular neurotransmitters. Then fourth one is the voltage gated channels, and voltage gated channels are open and closed in response to a particular voltage change. For example, if there is a excitability in the membrane, then there are 2 types of channels are there. When the sodium channel and potassium channels are there, the sodium channels basically have the 3 states. One is the resting stage. In its resting stage, their inactivation channel is open and activation channel is closed. And in activation state, both the channels are open, and again the third stage is inactivation state, where both the channels are closed. So okay, so here then there is in a cell there is a resting membrane potential around the cells, or which is during a normal stage. In a resting stage, that resting potential is developed due to the difference in ions, or which is basically you can say it's a negative, that's the inside membrane is negative in comparison to the outside environment of a cell. Or this basically you can say there is a negative charge inside the cytosolic region of a neuron, for which this charge is vary from 40 to 7 minus 40 to minus 70 millimeter of volt, minus 90 millimeter of volt, or this in actual the 70 the average potential of a cell, or this when these cells they exhibit this membrane potential, they are said to be polarized. Then the next what are the reasons for that development of charge? So there are three major factors which contribute for the development of these charge on the membrane. One is the unequal distribution of ion across the plasma membrane and selective permeability for the membrane for sodium and potassium. You know that there is a difference ion in extracellular intracellular environment, or the membrane is selectively permeable for different ions. For example, the membrane have the more leaky channels for the potassium ion in comparison to the sodium ion. It means that the potassium ion leak more to the outside environment than the sodium ion, or which lead to this membrane potential. Apart from that, there are in the outside environment there are sodium and calcium ions, so chloride ions, and in the inside environment there is a potassium and phosphate ion which present inside the in internal environment, cytosolic environment of the this cytosol of the membrane. Or most of these ions, or they contribute the development of membrane potential. Other thing is that there is a, most of the anions cannot leave the cell. As you know, that's most of the ions, chloride is the ions present in the phosphate or other form. Phosphate it bind in the form of ATP. They bind with the proteins which is the ATP and other ions bind to the amino acids and protein molecules which present inside the cell. They are not in the free form except the potassium ion. And third one, the sodium potassium pump, which are also an electrogenic pump, which put these, it try the cell for the resting potential. It try to those sodium ions back to the extracellular environment, or this in this way it transfer 3 molecules of sodium to inside and 2 molecules of potassium outside. Though the potassium ions are leak more, and they come this they utilize the ATP, and for a particular one ATP they pass the 3 sodium and 2 potassium ion outside, 3 sodium ion inside. And these pump they are in that way they are electrogenetic. They are, and as the pump is transfer the sodium from outside to the inside environment, as you know that there are more leaky channel of potassium, they pass back to the environment.